EET 114, Chapter 15 Series AC Circuits, Example Problem 4. It's an inductive element. For the inductive element shown here below, calculate the reactance of the inductor. So the reactance of any inductor is omega times L. Omega is given to you right here is at 750. And then the inductance is 40 millihenries. So 750 radians per second times 40 millihenries is equal to 30 ohms. As you can see, I did it over here on the board. Part 2 says write the voltage in phasor form. So the voltage is given in sinusoidal form here. You take that 200 times 10 to the negative 6 and you divide it by the square root of 2 as so, and you get 141.42 times 10 to the negative 6th volts, and the angle is a plus 90 angle. So that's the phasor. Oh, jumped over too far. So that's what the phasor looks like for the voltage across the inductor. Part C says calculate the current through the inductor in phasor form. So the current is going to be VL divided by X sub L, and VL is what we calculated. X sub L is going to be, we already calculated X sub L as 30 ohms, so it'd be 30 ohms at an angle 90. That's the definition of an inductor. It always has a positive 90 phase angle. So when you do the math here, you get that 142.42 microvolts divided by 30 equals 4.71 microamps. And then the 90 in the numerator, subtract the 90 in the denominator equals 0. So that's what that looks like. I did the same thing on the board here. And then part D says sketch the phasor diagram of the voltage and current. So I did that over here. The phasor diagram of the voltage is going to be plus 90, and it's a value of 141 microvolts. The current is 4.71 microamps, and it's an angle of 0, so there isn't much to look at on this phasor diagram. Part E says write the current in sinusoidal format. So you take that current at 4.71 microamps, you multiply by the square root of 2, and then sine of 750t plus 0 phase angle ends up equaling 6.66 times 10 to the negative 6 sine of 750t. And then part F says sketch the waveform of the voltage and current. So here's the voltage, here's the current. And if we look over at this, I also did part E over here. If we look at the sinusoid, I graphed this. This is about a period and a half. And V sub L is the blue, and it has a plus of 90, so it's pushed to the left over here where it crosses the 0 crossing right here. And then I sub L has a much smaller magnitude, and it's at 0, so it crosses at the origin right here. And you can see that the current lags the voltage. The voltage leads the current because the voltage is crossing over here, and then the current doesn't cross until over here, so the voltage is leading in time. This is the time axis right here. So the current lags the voltage. So this is an inductor. Remember it's Eli. So the voltage, the current comes after the voltage, or the voltage comes before the current.